Hello everybody, how are you? I hope you guys are fine over there and I am also fine here. It's me, Vijay Puri. I am here with my third video. We have already gone through two videos yesterday and the day before yesterday. So in those two videos we talked about remote entrance syllabus of IOE entrance examinations and also brief questionnaires and practice to set theory of mathematics. Yes, you people have seen here units and dimension, and today's, as promised yesterday, I came here with units and dimension and I'm going to present you few MCQs on units and dimension. That is I am here to present to give you idea about what types of questions are asked in units and dimension, the first chapter of physics. Yes, okay, before starting this topic I want to tell you that again the same thing. If you are watching this video on my channel for the first time, then please like and subscribe my channel and tell your friends to subscribe as well, because in upcoming entrance preparation period I will be helping you guys with these types of educational stuffs a lot. And another thing, as promised yesterday, I told you guys that you people that I will be practicing questions from unit and dimension from my book Entrance Physics today. So as promised, as yesterday, I am going to directly into those MCQs from the chapter units and dimension. So without talking too much, let's start some questions. So I am going to write example 1.2 from entrance physics. That is, these MCQs are from entrance physics. Remember, example 1.2. so the question is, the length of a pipe is measured as 100 centimeter. The magnitude of length of pipe is measured in units of 1000 centimeter will be 110 1 0.1. Yes, so the length of a pipe is measured as 100 centimeter. That means its magnitude is 100 and its expressed unit is centimeter. But according to the question, now we have to express this length of the pipe in the format that magnitude into unit, but unit here according to the question will be 1000 centimeters. So from this chapter we know that for any physical quantity, magnitude times units remains what? Constant. That is mu equal to constant. So the length of the pipe is measured as 100 centimeter. That means for this case magnitude is 100 and unit is centimeter. Are you getting it? So in the second times, if this expression is constant, we have to find magnitude of length of pipe, but in that scenario units will be 1000 centimeter. Let's say that magnitude is m, and in that scenario unit will be 1000 centimeter. So this centimeter gets cancelled and m equal to 100 divided by 1000, which will be 0.1. so the right answer for this question is 0.1. So remember one thing, from these units and dimensions, generally the questions asked will be of weightage of 1 marks. That is, generally short questions asked, short questions will be asked from this chapter. If we go through the past trends of questions, and we found you people can found in my book EPCM as well, where which is rich in past question collections, that generally units and dimensions contribute for 1 marks in physics paper of IO entrance examinations. So without talking too much, I want to proceed to next question. So next question will be discussed here. So example 1.2 of entrance physics and entrance physics from chapter units and dimensions is already discussed here, and I am going to write now another questions which is explained, which is listed in example 1.4 of that chapter in my book. So example 1.4, which is 1 Newton equals to 10 to the power 4 dyne, 10 to the power 5, 10 to the power 6, 10 to the power 7. So you have to remember that one of the major application of units and dimension is to change the physical quantity from one system of units to another. So this is the question asked from that topic. So for changing physical quantity from one system of units to another, we have what? The same thing, magnitude and units. Product of magnitude and units remains constant. So we can write magnitude initial. So let's write magnitude in a small letter. Magnitude initial times dimension initial equal to magnitude final dimension final. So here initial thing is given thing, that means initial is 1 Newton, which is expressed in what? SI units. So if you look upon these options, you will find that units is dynes, which is expressed in CGS. That means we have to convert SI unit measurement into CGS measurement. So we have to calculate this M final, but in terms of CGS. So we can express this formula as M final is equal to magnitude in initial into magnitude in initial into, get these terms over here. You can also use bracket here, small bracket. There is no need to use large bracket. So we can write M final is equal to M initial times Mi by MF A Li by LF B into Ti by TF C. So we can express this final and initial as in SI and CGS. So M CGS is equal to M SI into, so initial M SI M CGS times A. What is A? For that you have to know that what is Newton. Newton is units of force, and whose dimensions is M L T to the power minus 2. So this indices is A, this indices is B, and this indices is C. That is A equal to 1, B equal to 1, C equal to minus 2. That means what? 1 into L SI by L CGS into 1 T SI by T CGS to the power minus 2. So we can directly write what? MSI, magnitude in SI unit, what? 1. So units in SI is kg, in CGS gram to the power 1. The unit of length in SI is meter, in CGS centimeter to the power 1. The units of time in SI unit is second, and also in CGS is second 2. So are you getting this? So from here we can convert into CGS system. So before writing this, I would like to rub this part and just copy the bottom part in this section. So M CGS will be now 1 into, change these units in same units. That will result into what? Value of or magnitude of quantity in CGS system. So 1 into, if I change kg into gram, then it will be 1000 gram by gram to the power 1. Similarly meter centimeter, so 100 centimeter by centimeter to the power 1. And remember, if both these are expressed in second, so it will be 1, and 1 to the power minus 2. The indices to 1, any indices to 1 will result into 1 for real number of indices. Okay, then it is 1. So we will get gram gets cancelled, cm gets cancelled, we will get 10 to the power 5. that is our result will be 1 Newton is equal to 10 to the power 5 dynes. So this question is actually presented in example 1.4 of units and dimension of my in my book Entrance Physics. So this is the second question I have explained it to here. These questions have been included in today's session so as to give idea about what types of questions are generally asked from units and dimensions in the IOE entrance examinations. So changing physical quantity from one system of unit to another system of unit has also got huge importance in IOE entrance examinations. You people have to keep in mind about these things also. So without talking too much, let's move towards the third question. I am getting it. I am moving a little bit fast so as to cover as many questions in very short span of time. So third questions, now we are going to solve two more questions, and these types of questions are most important questions from units and dimensions, are generally asked very often in IOE entrance examinations. So I am going to solve two more questions in the equation format in which you have to find the dimensions of constant quantities. So let's move towards another question, and that is example 1.5 of units and dimensions in my book Entrance Physics. Example 1.5. The velocity of a particle is expressed as v equals to a plus b divided by t plus ct square, where t is time. The dimensions of c is, the options are L t raised to the power minus 1, L t raised to the power 1, L t raised to the power minus 3, L t raised to the power 3. So this is the question and these are the options given. So we have to keep in mind that this is an expression in which velocity of a particle is related to time, and A, B, C are the constants which are not defined to us. Among those constants we have to find the dimensions of C, that is only one constant. So while dealing with these types of problem, we have to keep in mind about principle of homogeneity in dimensions. That is, dimensions on the right hand side of an equation should be equal to dimensions of that left hand side. Another thing we have to know is that the terms with same dimensions can be added or subtracted. That means if here A is added to B by T or CT square, that means dimensions of A, dimensions of combined B by T and dimensions of CT squares must be same, and which actually are dimensions of V according to principle of homogeneity. So we can write dimensions of velocity is equal to dimensions of CT square. So dimensions of velocity is L t raised to the power minus 1 is equal to dimension of C into dimension of T square. That is L t raised to the power minus 1 dimension of C into dimensions of T square is simply capital T raised to the power 2. That is dimensions of C is equal to L t raised to the power minus 1 by T raised to the power 2, which is L t raised to the power minus 3, which is required answer. That is option C is the right answer. So again I want to tell that while dealing with these types of problem, please keep in mind that the quantities with same dimensions can be added or subtracted, and also the principle of homogeneity in mind. That is, the dimensions on the left hand side of an equation should be equal to dimensions of right hand side. Okay, so remember these types of questions are heavily asked and must asked question in IOE entrance examinations. So high frequency questions in IOE entrance, you have to get as many as questions of these types, and you have to solve or you have to practice very large number of these types of questions to get confidence on units and dimension. Okay, so we have solved 3 questions or 3 examples on units and dimensions from my book Entrance Physics. Let's move towards the last questions of today's session. So I'm going to write last questions here, and which is very famous question. That questions you have also practiced in your plus 2 levels. So before moving to that question, oh, it's very cold. I am going to drink some water. Okay, so I'm going to write last questions of today's session. Have you listened Van der Waals equation of state? Yes, that is very famous question in units and dimension, and the same questions I'm going to write here and explain the dimensions perspective on that questions. So this is in fact explained in example 1.6 of my entrance physics or first chapter. Okay, let's write the last question and discuss on it. So it is example 1.6. Example 1.6. In Van der Waals equation of state given is P plus A by V square V minus B is equal to RT, where P, V and T are pressure, volume and temperature. R is gas constant. The dimensions of A and B are, so M0, L3, T0, ML5, T minus 2, M0, L3, T0, ML6, T minus 2, M0, L3, T0, ML5, T2, M0, L3, T0, ML5, L6, T2. So the options expressed here and in the book are different, but I have got right answer over here. You don't have to worry. This is the very famous question in units and dimension, and it is indeed Van der Waals equation of state, which you have already studied in chemistry, I think, in your plus 2 level. So in these equations, it is P, yes, it is P, and P is pressure, V is volume, R is gas constant, T is temperature, and we have two constants A and B over here. So we have to determine the dimension of A and B. Okay, so let's move toward this question. So here I have already told in previous questions that the quantity with same dimensions can be added or subtracted. Are you remembering that part? Yes, if you remember that part, then it is very simple. Here B is subtracted from volume, so B should have dimension of volume. Similarly, A by V square is added to pressure, that means dimensions of this combined A by V square should be equal to is that of pressure. That logic is implemented here to find dimensions of A and B. Okay, so I am rubbing off these questions so as to solve the answer, because I have got very few space in my whiteboard which will be appearing towards or to you people. So okay, I am leaving out options here so as to get right at the end of this question. Okay, so we can write from the equation, first part, dimension of pressure is equal to dimension of A by volume square. That means dimension of A is equal to dimension of pressure times dimension of volume square. So what is the dimension of pressure? Newton per meter square. Are you getting it? Newton per meter square. What is Newton? Kilogram meter per second square. Newton per meter square, kilogram meter per second square. That means kilogram per meter per second square. M L minus 1 T minus 2 will be dimension of pressure. You have to be very fast in these simple dimensions of physical quantities like force, pressure, energy. You have to be very careful, because if you give too much time on dimensions of this individual physical quantity, then you cannot solve these questions in very short time. So you have to remember dimensions of these individual physical quantities like force, pressure, energy, resistance, capacitance, and so on. So dimension of pressure is Newton per meter square, kilogram meter per second square per meter square. else kilogram per meter per second square. Is it? So m for kilogram per meter, L to the power minus 1 for per meter, and per second square, T to the power minus 2. And what is the dimension of V square? Or simply we can write dimension of V square. So volume has dimensions of L raised to the power 3. So it is L6, that is m L5 T minus 2. m L5 T minus 2. Yes. So after determining the dimensions of A, you can look into the option m L5 T minus 2. Here is only one option, m L5 T minus 2. Yes, this can be our right answer. This can be our right option. Before ticking into this option, let's also find the dimension of B as well. So it is simple. Are you remembering that equation? V minus B, V minus B. Yes, in Van der Waals equation of state, P plus A by V square times V minus B equal to RT. That means dimension of B will be equal to dimension of B. So simply dimension of B is equal to, what is the dimension of volume? L cube. Yes, it is m0 L raised to the power 3 T0. So yes, we have right answer in options A. Yes, you have to solve these types of question very fast. Okay, so I want to end today's session in these 4 questions which are heavily asked or frequently asked from the chapter units and dimensions IOE entrance examinations, and I am focusing in the latter 2 questions to you people, because these types of equation and determining the dimensions of constant are very important from this chapter. And remember, generally the weightage of questions from this chapter is 1 mark. So generally short questions of these types are asked in IOE entrance examination, and you have to solve those questions very fast within 30 to 40 seconds. So at last, how you people are enjoying my class? You can give feedback in comment sections of these videos, or yes, again I want to tell, or through group page you have got many more things to interact with me through these online or internet things. Yes, so one of the thing is EPCM2077 Facebook group. Yes, get added to this group and interact with me for your entrance preparation period. Another thing is, yes, again I am writing entrance physics and EPCM. This is Facebook page. You can directly send message to me on any confusion through this page, because this page has got a send message option in Facebook. And another thing, yes, you can visit my channel, Vijay Puri channel, YouTube channel, and you can watch those videos and you can give me feedback also over there. So at last, I have taken 4 questions from entrance physics, especially from its first chapter, that is units and dimension, and these 4 questions are solved in example 1.2, 1.4, 1.5 and 1.6. and remember, I have solved 13 questions in the first chapter in example, and there are around 22 questions in the exercise section with solution. Yes, these types of patterns are followed in my book, and I clearly stated short multiple choice questions in the first chapter, because generally the questions from this chapter will be of short type. Yes, I am telling you frequently, because I have written this book in intensity pattern, that is look at vector. So vector is that type of chapter from which both long and short questions are asked. And yes, I have divided the exercise of this chapter into 2 sections, LMCQs and SMCQs. SMCQs contains short questions and its solutions are presented later at the book, and LMCQs are long questions, so as to cover whole the course of every chapter in very less volume. Okay, so before ending up today's session, I want to tell you that prepare best, stay safe, and interact me through this group page or even through my channel in comment section. So bye bye, have best time and prepare.